Right, so we are now talking about question 13. A car of mass 1400 kg has a maximum output power of 90 kilowatts, right? So that's the maximum it can give. If it is able to travel up a slope of 30 degrees with a top speed of 46 kilometers per hour, determine the top speed it can achieve when it's traveling on a level road. Assume the air resistance it experiences is proportional to the square of the speed and no other resistive forces are present. This is a challenging question, right? Because even though the question is very short, there are so many things that is expected, right? That you are expected to know. So, so let's first start with a diagram, right? As per usual, let's start with a diagram. So when you are traveling up a slope, this is driving force up the slope. There's friction downwards or air resistance, right? Or the other everything combined friction backwards. Okay. Your weight will actually also have a component of force down the slope. Okay, this is the first thing that you should realize when you're up the slope. Right? So if you look at this, my students were telling me that they still have some issues with the resolving, so I should do this carefully. So let me draw a rectangle and rotate it. Right? So if I also format the stroke, the scene will become clear. Right? Then I can adjust this. Right? So you see, the you see, so I can actually resolve this weight right to the component that is perpendicular to the slope, which is inwards, right, inwards. But this is actually no value to us because whatever this green arrow is, there will be a normal reaction force N that will be the same value of it, so the car doesn't go into the slope of the slope. Okay, what is of value to us is actually this line, the component of weight down the slope, which we can tell easily that is actually W sine 30 degrees because this arrow, this length of this arrow is the length of this arrow, this line, right? And you can see that the one below is just W sine 30. Okay, so that's something to realize. All right, what's next? Okay, is this at constant speed, acceleration equals to 0. So net force F equals to ma, which means that the forward driving force Fd minus the friction minus mg sine theta 30 degrees, right? In this case, mg sine theta equals to 0, which means that the driving force is mg sine theta plus friction. So here, this is where we apply the other information that the friction is proportional to the square of the speed, okay, to get this equation. So we have already something that looks a little bit scary, but it's not that different from question 12. Let's do the next one. Since power is force times velocity, right, then we are able to get this. We just sub in everything that we derived earlier for the driving force multiplied by v, we get power as this function. So power is a function of something times v and something else times v cubed. What's next? So we now sub in the values, right, to find the value of k, right, because this is the general formula for all situations of different slopes and different velocities. If you sub in this value, and k is a constant, so you sub in this value, you get k equals to 1. Very nicely, the teacher actually, the question setter has actually set it as k equals to 1. So you can then rewrite this equation, right, as this, right, because on constant road, right, the k is the same value, but now this component mgv sine theta pi becomes 0. Then you get driving force equals to k v square for driving force. Power is driving force times v, so it's k v cube, right? So since k equals to 1, right, you can then find the value of v quite directly. You find that it's 44.8 meters per second. But if you write it in kilometers per hour, because you're given in kilometers per hour, you get 161 kilometers per hour. So that's what you get. Right, so this is a challenging question. Yeah, let me know if you have any questions.